we are going to talk about ellipses now. And here's the definition of an ellipse, and all this will be on the paper that I've posted on the other thing. Ellipse is a fixed set of all points, and every point on here is the same distance. Like if I have this dot here and I draw a straight line to that dot and a straight line to that dot, and if I do it here to the two dots, the total of those two distances is always the same. Okay, those two dots are called the foci, basically meaning eyes, kind of, if you think about it. It's the focus. Now, I think an ellipse looks like, Stewie? I think it looks like Stewie. So you always want to make sure that Stewie's eyes are going the way Stewie's eyes do on the long, what we call the major axis, what we call the long axis, and this is the minor axis. Think major league is big league, minor league is smaller. But an ellipse can go like this or like this, but the eyes are always on the long one, just like Stewie's eyes would be if he was turning his head. Okay, so things that we need to know. I'm going to go to the paper here, if I can find it. Okay, there's the definition. I'm going to show you the video of what I was talking about. This is kind of cool. You can actually make an ellipse, and I bet people in construction have made these before because they kind of like to put those little windows in bathrooms and stuff. If you have a set length, so the two dots are going to be the foci, and then they tie a string around it and watch what they do. So they tie this string and they get a pen and they keep it tight. And there's the ellipse. So then the foci are on the inside. That's the major axis, and that's the minor axis. Now you could look at it with this little cartoon thing too. See the blue and the red, they straightened it out. The length of the whole thing is always going to be the same, but sometimes the red piece will be longer and sometimes the blue piece will be longer. But they can trace around it, like watch. So the red piece is getting longer and the blue piece is getting shorter, and it makes that cool ellipse. Okay, so that's where it comes from. Where's the notes here? Okay, so it's kind of like an oval. Think Stewie from the Family Guy. The eyes go on the major axis, which is the long axis. Okay, now there's going to be numbers and there's going to be fractions because the formula I'll show you in the next page. But you need to know that the big denominator is always the a squared. It's always the major axis. And that big denominator we'll find first because it will tell us which way our Stewie head is going to go. The small denominator is going to be b squared, and that's going to be the short one. This formula looks like Pythagorean theorem, but it is not. It is a minus sign, and that's going to tell us how far to count for the eyes. And then the center is still going to be HK, X from X, Y from Y. Okay, so here are the two equations. So like I said, they're going to have fractions now, and it always equals 1. When we talk about hyperbolas later, they will always equal 1 as well, so it'll be something that we do. Today, all of the centers are going to be at 0, 0, so we're not going to have any parentheses around the x or y. But do you see how the a squared is under x here? Just because a is going to be the bigger number, and if a is under the bigger numbers under x, then it's going to be bigger in the x direction, and it's a normal Stewie head. If the big number is under y, it's going to be bigger in the y direction, and Stewie head is going to go this way. The C is where the eyes come, and that comes from that formula, a squared minus b squared equals c squared. Now, some of you do like to memorize formulas. If you want to write any of this stuff down here on these 2 pages, you can. I prefer to do counting and less memorizing, but you're welcome to write this down or this down. When you do examples on my math lab, that's probably how they're going to help you. Okay, so let's do an example here. They're going to give us this graph, and we are going to graph it and tell about all the important parts. And I know I already forgot to tell you something. I told you about the major axis and the minor axis. The major axis here is in the x direction and here in the y direction. The points at the end of the major axis are called the vertices. And the short ones are called the co-vertices. So these would be the co-vertices, and these would be the vertices. So I did forget to tell you that. But we are going to do this problem. And I think you're going to think that ellipses are not too bad. I don't think they're too bad. So let's see what you think. Okay, so the first thing you do is you have to know it's an ellipse, and it's going to be easy for you to know it's an ellipse today because that's what we're talking about. But usually it's because there's a plus sign here and it equals 1. Fractions plus signs equal 1. So then you find the big number. And the big number is always going to be the a squared. And I have a squared is going to be 25 here. And because a squared is under the x, it's going to go in the x direction, which means it's going to be bigger in the x direction. There's no parentheses today because all the centers are at 0, 0. Okay, so the x direction, we need to figure out where the vertices are. And the vertices are at the end of a. So we're going to square root both sides, and a equals 5. So I'm going to count 5 in the x direction, and those are my vertices. So my vertices are going to be 5, 0, and negative 5, 0. Okay, the co-vertices come from the smaller number, and that will be b squared. B squared is 16, so b is 4. B is under the y, so in the y direction, I'm going to go 4 up and 4 down. And those are my co-vertices. They don't always ask you that, but that will be 0, 4, and 0, negative 4. That's enough for you to draw it, but you can't really have an ellipse. Oh, this is going to be so bad. You can't really have an ellipse without your foci. So we need to figure, I'm sorry that happened. Does that make you sad? That's better. Oh, I don't even, oh my gosh, that looks better. Okay, that's better. So to find out c, we're going to do a squared minus b squared equals c squared. So a squared is the big number, minus 16 equals c squared. 9 is c squared. And this is nice because it's a nice number. A lot of times it's going to be a square root, guys. So 3 is c. The foci is where the eyes would be. Okay, so it's going to be in the x direction. So you're going to count 3 from the center in each direction for Stewie's eyes. And the focus is going to be 3, 0, and negative 3, 0. Okay, so that's what we got. That's all you have to do with these ellipses. Okay, now this one is a little bit different because it doesn't have the fractions and it doesn't equal 1. So what we're going to do here is we need to, and we'll be doing this the rest of the year, is we need to make it equal 1. So how do we make it equal 1? We will be dividing everything by 36, and you will be simplifying these fractions. 9 over 36, that's x squared over 4, plus y squared over 9 equals 1. Now you know it's an ellipse because it equals 1 and has a plus sign. Frequently, those numbers will flip-flop down below on these problems. Okay, so the big number is a squared, and a squared is 9, which means a is 3. It's under the y, so that's going in the y direction this time. So Stewie's head is going to go up and down this time. Okay, and that tells you the vertices are 0, 3, and 0, negative 3. The co-vertices come from the b squared. B squared is 4. B is 2. It's under the x, so that's in the x direction. Those are your co-vertices, which is enough for you to draw the ellipse. So we can draw it now, but we still need to find Stewie's eyes, the foci. So it's a squared minus b squared equals c squared. 9 minus 4 is c squared. So 5 is c squared, and this is what I was talking about. C is going to be the square root of 5, which is fine for putting it on graphs. And remember, Stewie's eyes are going to be on the long side here. You're going to count about 2.2. That's what you're going to count. But we don't want, when we do the math lab, his eyes look stupid here. They don't want you to put 2.2. They want you to put the square root of 5. So you need to say, where are these foci? You got to use your brain here. I'm over 0, but I went up to 2.2, which is the square root of 5. And then I was over 0 and I went down the square root of 5. So make sure you use the exact numbers there. Okay. That's it for that example. I don't know if I have anything else for you or not. That might be it. Ooh. Well, I must have closed it out. Yeah, I think it is. Okay, we did it. Good job.